Hello, everyone. Could you hear me? Okay. Now let's start our second day of training. And today we will look at the one moment. We will to learn the technical principle and applications of VXLAN. And I think it is a very important part of the HCA DCN. And maybe it will occupy a lot of part of the examination. So maybe I will stay we will spend a whole day to learn this part, the VXLAN, its principle and applications. Wait a moment. And now let's look at the content of this part. And first, let's look at the forward, why we need to use the VXLAN and how do we use it. And nowadays, the cloud computing, it have already become a new form of enterprise IT in contrast, just because we can use it to so many advantages. For example, it has the high system utilize, and it costs low labors, and we can just reduce the management cost. All those factors will let the enterprise to use the cloud computer. And compared to the traditional network, the cloud compute, it requires a different network environment. All right. So we need to use some new technologies to build a different network to meet the requirement of the cloud computer. So that is the VXLAN. And what is the VXLAN? The VXLAN, you will find that it just wait a moment. I need to. You will find that it's just a little bit like the VLAN. All right, VLAN is the which line, and the VXLAN is the which extensible LAN. So maybe you will find that it has some relationship with the VLAN, and it is used to build the overlaid network, and it can just solve some problems that VLAN cannot solve. So now we will learn why we need to use the VXLAN and what is the requirement of the cloud computing, so that we need to develop a new technology that we call VXLAN. All right, now this is the objectives of this lessons. After we finish this lessons, we should be able to describe the network requirement of the DC and how VXLAN meet those requirements. And we need to learn the basic concept of VXLAN and the fundamental. And also, we will learn another technology, so we call it as UVPN. And we will learn what is UVPN and how it works and why we need to use the UVPN. And after that, we will learn in the multicast network, what is the new requirement and challenging for the VXLAN, and how do we just to change the VXLAN to adjust the new change. And at last, we will just to learn the application of the interconnection of the VXLAN network. How do we connect different data centers that in different VXLAN domain? That is what we will learn in the last part. And now let's look at the first part of, of our content. It is the background of the VXLAN. So now let's look at the first part, the technical background. Why we need it? What is the technical background that introduces the new technologies that we call VXLAN? That is the virtualization. And what is the virtualization? And what is the relationship between virtualization and cloud computing? Some people maybe know it. We will know that cloud compute, we will see that it is more just like a business mode. It is not the specific technologies. And it is based on some technologies that we call it virtualization. What is virtualization? It means we can just use one physical resource to function as different which results. For example, if we have one CPU, just in traditional traditional ways, we can just use it for one users. But actually, you should know that the CPU is about multi-thread and multi-process. So actually, we can let one CPU we only have one core, core processor, but we can let it to be used for different people in the same time. So that is the utilization of the CPU, or we will see it. It is the utilization of the cloud compute resource. And actually, for other resource, for example, the network resource, the the other resource, for example, we will find that you will find that, for example, the network, the storage, and the computer, we can all make it to a virtualized resource. So for the network, for the cloud compute, its basic technologies is virtualizations, and virtualizations. Now we will see that it has a lot of advantages, and but it also have some different. Just to compare the the retro technologies. For example, so for the network or for the service, it will be different. For example, now in our now in the virtualization architectures, the survey maybe are deployed on which machines, not on the physical service. So what is the different? The different things is now maybe in one physical survey, we will have a lot of which machines, and they all deployed in this service. They share the same physical resource. For example, they share the same physical network adapters, and they share the same memories, and all the things is shared by this service. And now we just have one network adapter, but how let it work for different virtual machines? That is a problem. And now another requirement is very common in the virtualization network is the layer 2 extension. What it means? It means in the cloud compute network, we'll find that the virtual machines will find we have already see it. It is not a physical server. It is just a virtual machines. It is just like a file. You can just imagine as a file. We can copy it from one computer to another computer, and for the virtual machine, it is the same. It means it can immigrate from one physical service to another physical service, but after and before the migration, all the things about the virtual machines shall not be changed. It includes the network it includes IP address, the MAC address, and all the resource within the virtual machines shall not be changed. So that we will find something just we will feel a little bit strange. If the virtual machine is IP address, its MAC address does not change. So if it means before and after the migrations, the virtual machines should belong to the same layer 2 network, all right? Just because its IP address, its MAC address it does not change. So it means we need to a very large layer 2 network, just because sometimes the survey, for example, this survey is the survey that it belongs to before the migrations, and this survey is the virtual machine belongs to after the migrations, and the this survey one, and survey two, maybe they are belong to different data center in different city. So how do you build a layer 2 network just between different data centers? I know it is you can make it just by use the traditional VLAN technologies, but it is just you will feel it's sounds weird. who will use the VLAN technologies to build a huge layer 2 network just across the city, all right? So that is problem. How do we build a layer 2 network just cross through the different city? That is a problem. And now that is why we need to use the VXLAN. VXLAN can meet this requirement. And another requirement is the multi-tenant isolation. So what it means? It means for the cloud compute service provider, it will provide the results for different complaints. Every complaint will occupy we call resource, and this resource we will say it belong to a tenant. That is a tenant. So for the service provider, I mean the cloud computer service providers, business, a customer is a tenant, and tenant and tenant, they should be isolated into different resource domain region. So that is the problem. How do we just make the isolation in the network layer? That is problem. And now let's just do just a review. What is the challenge that we have already faced in the past years? The first one is we will find that is the VM quantities. Just trying to imagine, just before we use these technologies, I mean the visualization, one survey only have one real physical network adapter. It means one survey just have one MAC entry. And but now we use the VM, we use visualization technologies. Within one physical service, maybe we will have more than 10 or 20 or 30 numbers of virtual machines. So just for one survey, you will find that in the access switch, you will find we will have maybe more than just 30 MAC entries. So that is problem. You will find that the MAC address entry, we just it expand for a lot, but the MAC address table size of the layer 2 access device, it will not be so huge. It is small. So that is the first problem. And then the second problem is the isolation capabilities of the traditional technologies. I mean, for the VLAN, we all know that the VLAN is it only have 20 bit, all right, and the actually is the number that we can use for the VLAN ID. It is just is this, and we need to just for the VLAN ID 0 and for the one LAN ID this one, it should not be used. So the real number of VLAN that we can use is not too much, and you will find that we have already seen before. The virtual machine, it needed to belong to a level 2 network before and after migration. And for one tenant, I mean, for one customers, it should belong to isolation network. So that is a problem. If we only have the limited numbers of the VLAN ID, so how could we use VLAN, these technologies, to meet the requirement of the layer 2 extension, meet the requirement of the isolation? So that is problem. VLAN cannot be used to meet the requirement. And the second one is we have already said that VLAN, yes, we can, but who will use the VLAN to meet this requirement? I mean, before and after migration, we still belong to the same layer 2 network. That is impossible to use VLAN to meet this requirement. So you will find that with the traditional technologies, we can't to make the layer 2 network to make it like a very huge scope. All right, so that is problem. Now we have found that we have three challenges, and how do we solve it? That is the VXLAN. So what is the VXLAN? VXLAN, it means you can find that first, it is the VPN technologies. So if it is a VPN technology, so we can know that what is a VPN? VPN, it means we will have different layers. Maybe we will have overlay and we will have underlay. For the overlay, it is a logical network. For example, it can be a logical layer 3 network, or it can be a logical layer 2 network. It doesn't matter. But another thing is more important is we have a underlay layer. Underlay. The underlay, it can be, it can be distributed in different data centers. It doesn't matter, just because it doesn't matter where are the underlay located to. We just need to make sure for the underlay they can communication with each other by the level 3, and then they can build a logical overlay network. That is the VXLAN. It is a VLAN. So for the first requirement to build just a layer 2 extension network and with a huge scope, we can use these features. It is a VPN, so the scope of the network doesn't matter just because it's logical. So it can be as huge as impossible. All right. For example, from the from this contender to another contender, all right, from this city maybe in Hangzhou and another city maybe Los Angeles or in USA, it doesn't matter. So we can build a logical layer 2 network. It doesn't matter. And another things we need to learn about VXLAN is that its capital solution is like the Mac in UDP. So what it means? It means we will encapsulate the original frame, the layer 2 frame into the UDP, and then the UDP header will be encapsulated into the IP headers, and then now we can see it is a VPN, just a traditional VPN encapsulation, right? And now let's look at some concept or some terminologies about the VXLAN. For example, the first thing we need to learn about is what is underlay and what is overlay. So what is overlay? Overlay, it means it's a logical network. It doesn't matter, it don't have the relationship with the underlays. It means whatever the underlay is belongs to, it doesn't affect the overlays. So we will find that the overlay for the VXLAN technologies, it is a logical layer 2 network, logical layer 2 network, layer 2 network. And for the endpoint that encap and decap the packet, we will call it the VXLAN tunnel endpoint V types. It's just the terminologies, just like in the IPsec VPN, we will call the endpoint, we call it as the peer, all right, the IPsec peer, the AKE peer. And for the VXLAN, we call it V type. It means by using this device, the packet can into the overlays and can out the overlay. That is the endpoint we tap. And what is underlay? Underlay, it means we can use the various physical device to build the barrier network of the overlay network. All right, it means it is the basic of the network. And it will provide the basic capabilities, for example, the reachabilities and the reliabilities for the upper layer of the networks. So you need to learn the underlay network. This device, they should have the reachabilities with each other. And the underlay network has independent control and forwarding planning protocols. For example, you can use OSPF or the eBGP to use as a control plan. It doesn't matter which one you use. You just need to use one protocol that can communication with each other. That is the requirement. So if you want, you can also use the IPv4 or IPv6 static routers. It can make it doesn't make sense in some ways, but it just we don't will use that. Just we can use it in theory. And the underlay network is logically isolated from the overlay network and is unaware of the overlay network routers. All right. So if you have some just basic understanding of the VPN, you will find that what is the underlay, what is the overlays, and what is the function. And now let's look at in the data center networks, we have different overlay network types, and we need to just learn, we just know this concept. So we have three network types about the overlay. We call it as the network overlay, host overlay, and hybrid overlay. So what it means, network overlay, it means the V type. Do you remember what is V type? V type, it means the point that the capture into the VXLAN domain and out of the VXLAN domain. All right, so that is V type. And network overlay, it means all the V type, all the endpoint, it is functioned by the network device. So that is network overlay. And what is the host overlay? It means all the endpoint, all the V type is functioned by the V switch. Yes, V switch, it means the switch that function by a software. And this software is running in the physical service, and you will find that the physical service, it has a V switch built in, and it can just function like the traditional switch. It can just forward the frame, and it can forward the forwarders, and it can drop the frame. That is V switch. So it means which switch inside the survey, and it can also to function as the V type. It means it can encapsulate and decapsulate the VXLAN packet. That is the V switch. And what is the advantages or disadvantages between network overlay and host overlays? And I will just do something about them. For example, you will find that the physical, it has the V switch, and it can just to do the traditional VLAN cap, and it can also to do the VXLAN cap. So what is the problem? The problem is the VXLAN, its header is larger than the VLAN, so you need to a lot of change to the original frame. So all the operation, you need to cost the CPU resource. So if you use the physical network switch to function as the V type, it means for this V switch, it just needed a little work, and it will not cost so many CPU resource. But if you use the host overlay, it means the V switch, it needs to do a lot of work. For example, to do the VLAN cap, and transmit the VLAN cap to the VXLAN cap, and it needs to calculate a lot. So that is a problem. We will know that for this physical survey, it needed to just provide the resource for the virtual machines, and it also needed to provide the computer resource for the virtual switches. So if the V switch need occupy more and more resource of the computer resource or the other memory resource, so it means the less and less resource can be used for the virtual machines. So that's the problem. For example, if we can say we have 100% of computer resource, normally if we use the network overlay, it means this V switch just need to cost a little computer resource. For example, it just costs 2%. But if we use the host overlay, for example, maybe we will cost 30% of computer resource for the V switches, and now we only left 70% for the virtual machines. That is a problem. It depends on how do you build your network. For example, if you use the network overlays, it means the access switch, it should have the capabilities of function as a V type. Normally, to function as a V type, it requires the switch have a higher performance. It means it should be a high-end access switches. But if you use just the host overlays, it means you can just use the traditional, you can use the cheap access switch. So it depends on how do you cost your money? You can cost it on the access switcher. You can also cost on just buy high performance computer service. It depends on you. And what is the next hybrid? Hybrid, it just means you can just combine the network overlay and host overlays. For example, for this switch, it doesn't function as the V-type. So we use the access switcher to function as the V-type. And for this one, we use the survey to function as V-switch. That is the hybrid overlay. Now, let's look at how can we just deploy the overlay protocol. We have different ways. For example, we can use the menu ways. It means for the VXLAN, we will say it is a VPN. So for describe the VPN, we will use and just the terminologies we can tunnel. Tunnel, it means the virtual link between the between two physical entities. All right. For example, so for the IPsec VPN, we will say we can build IPsec tunnel between the IPsec peers. All right. And also for the VXLAN tunnels, we can also just build the VXLAN tunnels between the V-type. And we can, how do we create the tunnels? We can use the command line to create it manually. And also we can use the controller, all right? Just because the VXLAN, it just define the forwarding plan. It doesn't define how do we implement the control plan. So we can use the manually command lines, and also we can use the controller. It means we can use the SDN controllers. It means all the switches can register to the controllers, and just they can communication with each other, and then after learn some entries about the VXLAN control panel, and then it can just send a message to the controller, and then the controller can sync the information to the whole VXLAN domain. That is another way to implement the overlay protocol. Now let's look at the third part, the second part, the basic concept and fundamental of the VXLAN. Now we will really start to learn the VXLAN. First, we have already seen VXLAN is a technology, so we call it is the VPN, we call it the market UDP. So now let's look at the VXLAN packet format. How do we encapsulate the original data frame into the VXLAN handler, and how do we encapsulate the VXLAN handler into the outlay IP handler? That you can find that. For the original data frame, it will be encapsulated into the VXLAN handler, and the VXLAN handlers, you will find that it has the VXLAN flags. It has the reserved part, and also it has one part we call it VNI, and after the VNI, it is another part of the reserve. All right, and so what is VNI? VNI, it means the VXLAN network. It means the VXLAN network identities. You can just think that the VNI is something like the VLAN IDs. It is used to just define different packets that belong to different layer 2 network. That is the VNI. You can just think it is something like the VLAN ID. All right, and then you will find that the VXLAN headers is being encapsulated to the UDP headers. So what it means, and then you will find that we will use the alt IP headers just to carry the UDP headers over the underlying network. So what just you will find that for the alt IP handlers, we don't have any problem. It is used to meet the reliabilities between the V-types. But why we need to use the UDP header? What will happen if we don't use the UDP header? anything will happen. So now I will introduce you why we need to use the UDP headers. For the UDP headers, you will find that the destination UDP port is fixed. It is the 4789, all right? But for the source port, it is not fixed. It will change, all right? It is the hash value. So what it means? It means, for example, I will wait a moment. For example, now we have a topology. The topology is like that. That is the core device. This is core device. That is core device. Maybe it is core switch in the campus network. All right. And this is access switches. Access switches. And in each access switch, we have a service that connected to it. It is service and it is service. Now, the two services, maybe it is survey 1 and survey 2, they need to send message to each others. And the physical link is like that. The physical link is like that. You will find that it is a physical link. So you will find that now from the switch access switch 1 to access switch 2, the underlay, it has a ECMP link, all right? It has a ECMP link. It has a ECMP link. It has the ECMP link. And how do the access switch 1 will load balance the packet to different links? If you know something about the just the behavior of the access switches or the network device, you will find that it normally for the switches or for the router, it will just check the information. It will check the IP header and the transmission layer. It means is the UDP or the TCP. For example, if one packet, if two packets, they have different information. Maybe the information is the IP header, or the information is UDP headers. If they are different, the access switches, the network device will think they are the different. They are the different how to say that? They are different packet stream. All right, and for the different packet stream, it will not balance it to different ECMP links. So now you will find that if the access switch 1 is the V type and access switch 2 is the V type, you will find that for the packet, what will be different? Now the packet is sent from the access switch 1 to access switch 2. The outer IP header is fixed, all right? The source IP address and destination IP address is the same. And it is a VXLAN header, all right? So the destination UDP port is the same. So the only thing that can be different is the source UDP port. And it have already said it is a hash value. So what is the the original packet for the hash? It is this part. It is the original data frame. So you will find that if the original data frame is different, so the source UDP port will be different. And for the network device, it will think packet 1 and packet 2, the data frame is different, and the source UDP port will be different. If the source UDP port is different, the access switch will treat the two packets as different stream. So it will not balance the two packets to different ECMP links. So it can make the high utilization of the physical link of the all over the underlay. So now I think you have already understand why we need to use the source report as the hash value, not a fixed value. That is why. All right. Now let's look at some basic concept of the VXLAN. The first one is the NVE. So what is NVE? NVE, its full name is the Network Virtualization Edge. It is the entity that run VXLAN and construct the layer 2 virtual network over a on the networks. So you can find that in these topologies, switch 1 and switch 2, they are the NVEs, just because switch 1 and switch 2, they together built the VXLAN tunnel, so they are the NVE. So another just a similar concept or another similar terminologies is weight type. What is weight type? Weight type, it means the VXLAN tunnel endpoint. It is located on the NVE. You can just find that. weight type is a terminology that has a similar range of compared to the NVE, all right? And it is an entity that performs the cap solution and the decap solution. And in the outer layer behind of the VS packet, the source bit address is the IP address of the source bit type, and the destination IP address is the IP address of the destination bit type. So you can find that V type is something that inside NVE. So you will find that they are similar, but they are different. You can just find that for just maybe just for one NVE, it can has different NVE interface, and inside the NVE interface, you can just configure a lot of V type configuration. Now let's look at what is the VNR and BD. VNR I have already introduced it before. You can just imagine it. You can just think. You can just consider it is something like the VLAN ID. So what is different? The different is it has more numbers, and I thought it is just compared to the VLAN IDs. Its number is numerous. All right, it is huge. And what is the bridge domain? Bridge domain, you can just like its full name is the bridge domain. So you will find that it's something like the it is to define the broadcaster domain. But bridge domain is not a terminology that take effect globally. It just take effect locally. It means for this switch, it is switch 1, and for this switch, it is switch 2. They all have the bridge domain 20. And what it means? It means for this interface and for this interface, for switch 1, it belongs to a bridge domain, and this bridge domain, its name is 20. And it just take effect on switch 1. And for this switch 2, it also have an interface, and this interface belongs to the bridge domain or the broadcaster domain. We call it the bridge domain 20. But that it doesn't matter. All the real things that take matters is the VNIDs. You will know that VNID is the definition of the layer 2 network. So how do we know if PC1 and PC2 can communicate with each other if they are belong to the same subnet? It belong to it just we just need to look at the VN numbers. So it means on the switch 1 and switch 2, the BD number can be defined. For example, for the switch 1, the BD number can be 100, but for switch 2, we can define this bridge domain to the 200. It doesn't matter. Only we associate the same VN numbers into the bridge domain locally. They can communicate with each other. They belong to the same broadcaster domain in the logical network. Now let's look at what is the VXLAN access mode. It means we will know that we need to just let the traditional package from the VLAN or from the level 3 packet into the VXLAN network. So how do we do this? How do we achieve this? We can use two ways. The first way is we can use the layer 2 sub interface. For example, a layer 2 sub interface is created on switch and associated with BD time, and the specific traffic on the sub interface, and then will be forwarded to the BD time. And another mode is the VLAN bounding mode. For example, you can just inside this VLAN time, you can configure on switch 2 and associate with the between. It means on this device, you just make a link. You can make a association between the BD10 and VLAN 10. So that is the two access mode. Now let's look at what is the VXLAN gateways. We have two types of VXLAN gateways. The first type is the layer 2, which means layer 2. It means you can just think if a device is a V type, it is a layer 2 gateway. It means it can finish the function of that make the packet into the VXLAN domain. You can consider it as the layer 2 VXLAN gateway. That is the layer 2 VXLAN gateways. So what is the layer 3 gateways? Just imagine in our traditional VLAN network, we will find that we use the VLAN technologies to divide the network to different logical broadcast domain. And within the broadcast domain, we can use VLAN if interface to function as the layer 3 gateway, all right? And for the VXLAN, it is same. We can use the VBDIF interface, all right? VBDIF interface. It means interface that based on the BD. And you can use this interface to function as the layer 3 gateway inside this broadcast domain. That is the way we believe. So if a device that it is the V type, and also you configure the VBDIF on this device, we can consider it as the layer 3 gateway, all right? And then what is VBDIF? I have already introduced it before. We have seen that it is something like the VLAN if, and it is a gateway inside the VXLAN broadcast domain. All right, that is the VBDIF. It is the logical interface. And then we have two types of gateways. The first type, we call it the distributed. What it means? It means we can build, for example, for this one, PC1 and PC2, and PC3, you will find that for the PC1, its gateway is on this device. It means we will configure a VBDIF on this device for the PC1. And also for the PC2, we will configure a VBDIF on this device. And also for the PC3, you will find that PC3 are in the same subnet with the PC1. And we can also create the same VBDIF interface, just same with the VBD interface in these access switches, and this interface will function as the gateway for the PC3. And what is centralized gateway? It means all the VBD will be created on one device. Maybe this device is the core switch. Normally, it should be the core switch, and we will create all the gateway on this device, and then we will call it a centralized gateway. And now let's look at some application of the VXLAN in the DCs. In the data center network, we will use two layers, one layer for physical architectures. It means we will use this architectures. For the span, it means the core switches, and it only run the underlay IGP protocols, or maybe it's the BGP protocols, but it is only the underlay. It is only the underlays, and the overlays will be running within the access switches. I mean, all the leaf devices, they will run the overlay protocols. I mean, in this chapters, it is VXLAN. And all the span devices, they will only do the traditional layer 3 forward. And it is recommended that a VXLAN network with distributed gateways be deployed in the DCs. And why? You can just mark it with market, and we will answer it later. Understand now the forward packet based on the route and aware of VXLAN during traffic forwarding. Limit node provide network access for device resources such as service and perform VXLAN encapsulations and decapsulations. All service indices are carried by VXLAN network. So that is the application of the VLAN indices. And then we can look at the fundamental of the VXLAN. And the first things we need to learn about VXLAN is how do we establish the VXLAN tunnels. We have already introduced before. We can use the many ways, all right? So the first way is we can create a static VXLAN tunnels, all right, and manually configure it. And we need to configure the WinR numbers, the WTAP address, and the increase replication list by ourselves. And another way is we can use the dynamic VXLAN tunnels. It means, I don't know if you remember, I said before, the VXLAN only define the data plan, all right? It doesn't define the control plan. So we can use another protocol to function as its control plan. And BGP UAPN can be that protocols. So it means we can use the BGP UAPN to just change some information, and these informations can be used to establish the VXLAN tunnels. So you can just imagine, maybe this information can include the VNI, the VTAP address, and other things. All right, that is the BGP UAPN. And first, let's look at the static VXLAN tunnels. How do we configure it? You can find that this command line in the device. First, we need to create the NVE interface, and we need to configure the source interface. All the source IP address. It means which IP address will be used when you try to just construct a VXLAN packet. All right, this IP address will be used as the alt IP header. All right, and then peer list, what it means, peer list, you can just think it is the destination IP address of the IP alt IP header. All right, and what is VNI? VNI, it means when you try to construct a VXLAN packet. Now we have already the source alt IP address and the destination alt IP address. And what is the VNI numbers inside the VXLAN header? That is this. All right, so that is the command line of the static VXLAN tunnels. All right. And now let's look at the VXLAN MAC address entries. You will find that it is just the same like the traditional VLAN network. All right, you can find that it is reminiscent of the VLAN. All right, just one parameter is different. All right, in the VLAN network, we use this command display MAC address, and in the output, the parameter should be VLAN, but now the output, the parameter have already changed from VLAN to BD. That is the only difference. You will find the output will remain that, remain what? The output is remained you. The forwarding, the forwarding way is the reminiscent of the VLAN. It is the same. Yes, it doesn't change. So how the VLAN network forward the traffic, and then how will the VXLAN network traffic the packet, that is the same. All right, so now let's look at how does it work specific in detail. You find that VXLAN implement layer 2 forwarding on the overlay network. Unicast data frames are still forwarded based on MAC address entries, all right? And when a V type receive a data frame from the local BD, the V type adds the source MAC address of the data frame to the MAC address table of BD. And the outbound interface in the MAC address entry is the interface that receives the data frame. So you will find that this part, this word, all right? This part it is just like the work, it's just like the working principles of the VLAN. All right, just changes the VLAN to the BD, nothing change. And this entry will use to guide the forwarding of the data frames sent to terminals connected to this V type. All right, connected to this V type. For example, for the PC1 and the PC2, they are connected to the switch 2, and for switch 1 of switch 1 and switch 1, it message address table is looks like that. Okay, that is the output, and by use this message address entry, we can forward the packet that destined for the to the PC1 and PC2. Okay, but now it also, you will find that we encounter another problem. That is, how do we how do we forward the packet that destined to remote V type? That is problem. All right. Okay, now let's look at something about the control plan of the VXLAN. How do the dynamic manager table learning is work, and or we can just change a way to describe it. How do we form the dynamic manager table? All right. Now we have just terminologies and we have step. We can just to see it step one step. The first things we can find that we have a PC, the PC1 and the PC2. They are in the same subnet, all right? And for the PC1, its IP address is 1.1, and for the PC2, its IP address is 1.2, and the MAC address is just all right, just have a slight difference. And switch 1 and switch 2, they are also the layer 2 gateway, all right? And what is next? The next is for the switch 1 and the switch 2, they are also the V type, and the V type address have already been written in there, all right? So the first the first the first procedure is the PC1 will broadcast ARP request packet. All right, just because PC1 want to communication with the PC2, but now the PC1 don't have the MAC address entry or the ARP entries about the PC2, so it needed to send a broadcast ARP entries, all right, and the ARP frame will be encapsulated into the Ethernet harness, and then the frame will just reach the switch one, and the switch one, it will learn the source MAC address, all right, and it will form the first dynamic MAC address table entries, all right, it is this one, and then the switch one will find that the destination MAC address is the FFFF. All right, it represents broadcast frame. So the switch one will perform the VXLAN accept solution for the IP packet, and then it will forward the packet to all VTypes with the same VNI. All right, and then it means switch two will receive this VXLAN packet, and it will try to decapsulate the packet and find that the VNI inside the packet. All right, it is the VNI 1000, and it has a configurations of about the VNI 1000. So it will try to just check the it will check the inner frame information. All right, and then it will learn the MAC address of the about the PC1. So now the switch 2 have already formed the MAC address entries about the PC1, and then it will find that for the inner frame, all right, the destination MAC address is also the FFF. It means, or it represents the switch 2 need to broadcast the packet, all right, just inside the bridge domain, the inside the broadcast domain. So switch to forward the ARP packet to the PD2. So actually, it should not be forward. Be more specific. It should be switch to float the ARP packet to PC2. All right. that should be more specific. And then PC2 have already learned the ARPA information about the PC1, and now PC2 will send a unicast ARP reply packet to the switch 2, all right? And after receive this packet, this frame, the switch 2 will learn the MAC address about the PC2, and then now for this frame, it has the specific destination MAC address. So the switch 2 will try to do a MAC address entry lookup, all right, and you will find that it can meet exist entries, all right, it is this entries, and then it will cap the packet into the VXLAN handlers and send it to the switch 1. And after switch 1 receives this packet, it will try to capsulate the packet, and it will find that the destination IP MAC address can meet exist message entries. Also, before it folds this frame, it will learn this entry, all right, and then PC1 have already learned the ARP entries about the PC2 and vice versa, all right. So you will find that by this progress is also forward and learning, all right. It is still the forwarding and learnings, just like what I say for forwarding and learning, all right. Just like what I say, the control plan, just by default, the control plan is the reminiscent of the VLAN, all right. It doesn't you can find that the control plan of the VXLAN emphasize the VLAN control plans, they are the same, all right, nothing changed. Now let's look at the progress of the intra-subnet forwarding of the unicast packet with known destination address. So you will find that the PC1 will send the data frame to the PC2, and now the frame just reaches the switch 1, and the switch 1 it will try to do a level 2 entry or table entry lookup, all right, and it can find exist entries, and then it will forward this frame to the switch 2 with the VXLAN handle, all right, and then switch 2 receive this packet. It will try to decapsulate the packet, and it will find it has the VXLAN handles, and it will try to check the WinI numbers inside the VXLAN handle, and then it finds the WinI number. I mean the WinI 1000 is it have the corresponding configurations inside the WinI, so it will try to do the in the frame forwarding, all right. So it will find that it can meet exist entries, then this packet will be forwarded to PC2. That is the progress of the intra-subnet forwarding, all right. And now let's look at the inter-subnet forwarding of the unicast packet. What it will be look like. You'll find that for the PC1, all right. The PC1 it will assign the unicast frame to the PC2, all right. And after the switch 1 receive it, it will find that the destination IP address is we will find that the destination MAC address is belong to the switch 3, so it will send the frame to the switch 3 or just by the VXLAN tunnels. And after the switch 3 receives this packet, it will first it will find that this packet should be just processed by itself, and then it will try to check its destination MAC address. It will find that the destination MAC address is the MAC address of the one interface of itself. All right, I mean the interface should be the level 3 interface. So the switch 3 will realize the packet needed to be forward. I mean the level 3 forward. I mean the IP forward by itself. So it will try to check the IP room tables, and you will find that this packet that send by PC1 to the to the server 2. It should be it should just match the direct route, all right? Just because the switch 3 it have a two interface, VBD10 and VBD20, it will just reduce generate two direct route, all right? And then the switch 3 will forward the packet by the route tables. It will find that the next it is the direct routers, so it will try to find the IP address and then try to find the MAC address address. And the switch 3 will realize it should be forwarded to the switch 2. All right, and the switch 2, after switch 2 receives this packet, it will find that this packet should be forwarded to server 2. All right. And last, let's look at the bump traffic forwarding. So when the VXLAN network transmit the broadcast and unicast and multicast traffic, and all the traffic we call it the bump traffic. The local type will send multiple copies of the traffic to remote types in the ingress replication list. And it means for one packet, I mean the bump traffic, it is a wait type, the increased wait type needed to just copy it several times. So it will cost a lot of resource wise. So how do we do that? By default, we can just do this. It called the bump traffic forwardings. You can find that. But in the overlay network, we just to do some actions to just simulate the real broadcast network, but it is not real. It is not a real broadcast network. All right. And the next chapter is the EVP and VXLAN fundamentals, and I think maybe we can just take a rest for 10 minutes, and we can take a rest. All right. And wait a moment. Can you explain each other's questions? And maybe we can take a rest for 10 minutes. All right. And then we will continue. Now, everyone, after a short wait a moment, someone asked me questions. I have said that the device usually support a two-way interface when Y is used to have more than Y. Yeah, but good questions. And normally we just need to use one. And actually, you can find that you can use the different NVE interface. It can have a different source interface. So it means for this different VXLAN tunnels, you can use a different source interface. If you only use one NVE interface, it means you just can choose one interface to function as the source interface. So normally one in NV interface is we can just meet our requirement, and but actually I didn't see the real network. They will use a different NV interface and use different source address. So you will find that I have when I introduce the concept of the V type and NVE, I have already said inside NVE is a concept larger than the V type, all right. But if we only use one NVE interface, and actually sometimes you can consider they are equal. All right, now let's continue. Let's look at the European VXLAN fundamentals. And the first thing, when we need to learn new technologies, maybe we need to consider about why we need to use these technologies. And so we need to just introduce or we need to learn what is the disadvantages uh, of the manually built the Western tunnels. You can find that if we don't use just a control plan, we just configure the Western tunnel manually. You will find that for if we have more and more device, the Western tunnels that we need to configure just in one device, it will be huge, right? And if you just add another device and the number of the Western tunnel that need to be configured by ourselves, it will just I think it will just duplicate, all right? So that is cost a lot of labor. Another thing is that we have already seen it. VXLAN only define the forwarding the forwarding the traffic plan. It doesn't define the control plan. So the MAC address or you will find that for the forwarding entry, just in the VXLAN, you don't use any control plan protocols. It is still the forwarding and learning, all right? It is still forwarding and learning. So you will find that that is not a good way. It will cause a lot of traffic forwardings. And we have seen that for the VXLAN network, it is not the real broadcast, all right? It is uses the replication. It will replicate the packet. It will make the copy of the packet. So it is not the real the broadcast. So you will find that by this way, it will cause a lot of resource, all right? The computer resource, the network bandwidth resource. So that is another problem. Now so we will introduce another new control plan for the VXLAN, but we need to know one thing. This protocol, BGP European, it is not designed. I mean, it is not designed specific for the VXLAN protocols. So I mean, the European these protocols can just function as the control plan for several protocols, just because one protocol is a VXLAN. So we will introduce it, but not it is not specific only for VXLAN. We need to learn this point, and this point you will find that European, but it has a prefix. It is the BGP. So you will find that the BGP European it is a new how to say it is a new address family, right? And this address families can carry some information, and this information can help the V type to build the VXLAN tunnel just automatically. So that is the BGP European. So you find that BGP European, it is we can find that it is actually it is the if we just consider the protocol itself, it is not the control plan. It is just to carry some information, but to work with, to cooperate with the BGP European, we just define some just working process on the V type, and we can just, for example, after receive some BGP European routers, and the V type will do some corresponding actions, and then to help reduce the traffic flooding to improve the efficiency of the speed of the built the VXLAN tunnels. So that is the BGP EVPN. It is still just the protocol that is to transmit the route between different devices. All right. So now let's look at the overview of the BGP EVPN. The BGP EVPN extend BGP. We shall know that just because it is the sub-address family. Oh, okay, it is a new address families for the BGP. And it defines several new types of the BGP EVP routers use the network layer. You should know that if you know you are familiar with MPLS, you should know that it is the NLRR, all right? Its abbreviation is NLRR, okay, all right? And this information should be carried in the multi-protocol rich NLR attribute, all right? And so that is the problem. What information will be carried by this new NLR? You will find that it will transmit VTAP address, host information. What is the host information? Host information, it is the IP and MAC address about this host. That is the host information. Therefore, BGP UAPN is applied to VXLAN network to transfer VTAP discovery and host information learning from the data plan to the control plan. And we will see that it define three network routers. You will find that it have three routers: type 2 routers, type 3 routers, and type 5 routers. And type 2 routers, you will find that it will carry the MAC and IP information. So type 2 router is carry the host information. And what it means, IP, it is the IP address, all right? And so you can consider it as the host router. And for the MAC address, it is MAC address. If you compare IP address and MAC address, what new information, what thing you will get? You will find that you can be it together. You will get the AIP address, and if you just consider it separately, okay, this is MAC address address, and this is the host router. All right, so type 2 router carry the host information, and the host information can just how to say that you can find that the host information, all right, type 2, the host information can be MAC address entry, all right. It can be the host router, and also it can be the ARP entry, all right. So you can find that one entry, one router can be used for different entries. And then type 3 routers, it is the inclusive multicast routers. What is used? It is used to establish with type tunnel automatically. So it will carry the layer 2 WinR and VTAP address information. So it can be used to implement automatic VTAP discovery and dynamic VXLAN tunnel establishment. And also, it can be it can be used for the bump traffic forwarding. And type 5 router, also we can call it the IP prefix routers. You can just consider the type 5 routers just like the MPLS. Yes, you can just think that it is similar. It is to use the advanced host IP routers and external networks routers, but normally we will not use it to advise host IP routers. We use it to advise external network routers. And if you use to carry external network routers, you will find that it's just similar with the MPLS router. It is the same. And now we have already introduced the VPN, eVPN NLR. We have already said it is carried in the path attribute. We call it as the MP-rich NLRs. And the address families identified is the 25. And it is indicate it is the level 2 VPNs, and the subnet address family identifies is the 17. All right, it is represented for the VXLAN. And also for meet the requirement of the function, to meet the requirement to function as the control plane of the UVPN, we also define other extended communications. For example, we define the MAC mobilities, and we also define the UVPN routers MAC extended communicating, and that is a new extended communities. And also, we also have another extended communities I thought you should be very familiar with. That is the RT, yes, root target, the RT values. And what is used for? Just like how do you use the RT value in the MPLS network? See, the the way and the functions is the same. And now maybe we will introduce some new concept, and this concept will make you feel confused, feel maybe will sound weird and feel weird, but we need to try to understand it, and this is very important for understand how the BGP UPN function as the control plan for the VXLAN. So wait a moment. So this concept is the instance, but notice this instance is not the IPVPN instance, it is the eVPN instance. And this instance is bound to a BD. And so the MAC address entries in the BD are transmitted will be transmitted through the BGP UVPN routers. So you should know that the MAC address entries should be a host information, all right? So it should be the BGP UVPN type 2 router, all right? Type 2 routers, okay. And this router will carry the RT values. It will carry the RT values. And after a wait have received the UVPN routers, and it will compile the RT value. And also, you will find that the RT value should be the local UVPN instance RT value, all right? And if if the RT values is the same, and it will add the UVPN routers to the routing tables of the corresponding UVPN instance, and we know that this router is carry the host information. It will try to put the MAC address that carried by these routers into its install it is the entrance into its local MAC address tables. All right, so it will how it works. It will like this. For example, for the switch 1 and switch 2, they also have they have the same BD, but just like what I said, the BD doesn't matter. The VNR is the matter, all right. And now they have the eVPN sense, all right, eVPN sense, and they have the RD values, and they have the RT values, and just like the MPLS VPN, the RT values just have two directions, all right, egress RT values and import RT values and export RT values. And after we send the EVPN type 2 routers to the remote type, we will carry the export RT value, all right? And after the switch to receive these routers, it will try to pause the routers. It will try to find the RT value if the RT value is equal to some RT values that inside one local EVP instance. Okay, if it can find one instance that have the same RT values that can with the RT values carried in the BGP routers, it will try to install the MAC address that carried in the European routers into its local MAC address entry. All right. Now let's look at what is the BGP European routers, and inside the BGP European routers, we have the different types, all right. And the first type we have already said it is the type 2, and the type 2 it include the host information. So what is the host information? We have already said it: MAC address, AIP address, and host IP routers. But those three entries actually is they just they just how to say that? They just actually they are two informations, all right? Just the IP address and MAC address. So that is the information will be carried in the type 2 routers. And also they have two labels, and the first label is the MPLS label 1, and another label is the MPLS label 2. That is the terminology that is defined in the IFC. But if you try to imagine why the IFC define the two value as this name, you will know how the BGP UAPN works. And you will find that for the MPLS label 1, it is the level 2 WinR information. And also we have another information, it is the level 3 WinR information. And what is this? Maybe you have these questions, and we will try to understand it in the later page, all right? And now let's look at what is the different MAC router or IP router looks like. You will find that if the router carry different information, so we can call there are different type of the type 2 routers. For example, so we can say it is the host MAC address advancement, or it is the host AIP advancement, or we can say it is the host IP router advancement. So what is the different? For the first type, you need to carry the MAC address information and with the level 2 WinI. And if it is a host AIP host AIP advertisement, we just have has two more information compared to the host MAC address advertisement. All right, just carry a new information, that is the IP address length and IP address. And what is the next? The last is the host IP route advertisement. All right, we will find compared to the the just compared to the host IP advertisement. All right, it just have another new information. It is the level 3 WinR. What is the level 3 WinR? We don't know it. All right, but now it doesn't matter. It is not important. We will try to get understand it after in the later page. And now let's look at what is the host MAC address advertisement. Okay, this slide we will show the how BGP European routers will deliver the MAC address information. All right, now let's look at the first. Let's look at what is the topology looks like. In this topology, we have two PCs, the PC1 and PC2. The PC1, it has the IP address and the MAC address, and the PC1. Okay, this interface that connected to the switch 1. It is a level 2 gateways, and this interface have already bound to BD10. All right, and in this BD10, we configure the level 2 WIN informations, and we configure a UAPN instance informations. All right, we configure the RT values, and we configure the egress RT values. All right, and after the V type learn the MAC address about the PC1, and then it will generate a V type type 2 routers. And in this type 2 routers, it will carry the RD values, it will carry the MAC address, and also it will carry the WinR values, and also it will carry the eVPN RT values. All right, just in the RT values inside the BD10. All right, and then we type. I mean, the switch 2 will receive this packet. All right, it will try to how to say that differ. It will try to compare the RT value carried in the BGP update message with its local BDs import RT values. Try to find one BD that have the same important RT values with the EVPN IP values. All right. If it can find, it will try to install the MAC address that carried by the type 2 routers into its local MAC address tables. So you find that the switch 2 will install the MAC address in MAC address entrance, and now you will find that we don't have the process of forwarding and learning. All right, we don't have this progress forwarding and learning. But now we have already finished the control plan. We have already finished the progress of the MAC address learning. All right. And then let's look at what is the host AIP advertisement. This slide will show how type 2 route implement host API advancement. Why the BGP is used to construct a DCN in the distributed gateway scenarios. All right. And you will find that in these scenarios, the switch 1 and switch 2, they are the they are the level 3 gateways. They also have the same BD and they have the same level 2 VNS. And then the PC1, all right, maybe it generates ARP request, and this ARP request be received by the switch 1, and then the switch 1 will learn the ARP entries of the PC1, and then it will try to deliver the information to other types by use a BGP update message. And this message will carry the ID value, MAC address, IP address, and with the level 2 VNI information. And also it will carry the EVP ID values. After other type receives this BGP message, it will do the same procedures. It will try to parse the MAC address and IP address that carried in this BGP routers, and also it will try to compare the RT value that carried in the BGP update messages with the RT values that configured inside its local BD. All right, so the progress is the same. And then what will happen? The switch 2 will learn the ARP entries that carried by this BGP update message. All right. All right, now let's look at another questions, and these questions will be very important. That is the inter-subnet communication in distributed gateway scenarios. So now let's look at what is the problem. The problem is in the distributed gateway network. All right, gateway will function as both level 2 and level 3 gateways. In this network, inter-subnet communications can be implemented in different modes, just according to the progress mode of the ingress type that received packet. Inter-subnet communications can be classified into the asymmetric integrated routing and bridges and symmetric RB. So what is that? What is the symmetric RB and asymmetric RB? What is the difference? Just try to see the terminologies. Okay, see the terminologies. For example, in the traditional VLAN scenarios, the inter-subnet forwarding between VLANs we will through the VLAN if, but we will find that the VLAN if are in the same device. For example, for the PC1 and the PC2, the gateway are the VLAN if 10 and the VLAN if 20. They are in the same switch, all right? And so between the PC1 and the VLAN if 10, we can see the progress is bridging. It means it is a level 2 forward, all right? And between the VLAN 10 and between the VLAN 20s, we can see it is the routing progress, all right? Just because this switch, it will try to do the level 3 forwarding, all right? It will try to check the IP routing tables, all right? And after it checks the IP routing tables, it will still do the bridge. It means it will still do the level 2 forwarding information search, all right? And it will send the frame to the PC2. That is the progress of the inter-subnet forwarding between VLANs, all right? But now it have a problem. What is the problem? The problem is we have the distributed gateway, all right? It means either we have 2 and we have 10, we have 1 and 2. They can also have the VBDF10 and VBDF20s. So the problem is if the PC1 want to do communication with the PC2, first is the PC1 will send the packet to its gateway. It means this way VBDF10. But now problem is we know that within VBDF10 and VBDF20 we need to do the routing progress, all right? But with which one? We type 1 have the VBDF20. We type 2 also have the VBDF20s. So the routing progress is with 1. Is within the VBDF20 in its local vtype or with the remote VBDF. That can be different, all right? That can be different progress. The different progress just represent different ways. That is the asymmetric RB and symmetric RB. All right. So now let's look at what is the different. The first way is asymmetric RB. So what is asymmetric RB? Now let's look at. It means what? It means the English way type will search both level 3 and level 2 forwarding tables for the traffic forwarding at the same time. And the egress way type will only search the level 2 forwarding tables for traffic forwardings. So you'll find that egress way type and egress way type will function different. Will do different behavior. So that is the asymmetric. All right. So now let's look at the progress. The PC1 it tried to send the packet to the PC2. They are in the different subnet. So the progress is the inter-subnet progress. All right. And PC1 first will send the packet to its gateway. So the frame is the destination MAC address as frame is the gateway. All right. And then the packet will be received by the VType1 by the VBDF10, and then it find its destination MAC address is sent to VBDF10. So it try to pause the packet and check the IP handle. Okay, it will check the IP destination information, and then it will try to search the routing table. All right, it will try to search the routing table. Wait a moment, it try to search the routing table, and it will find that the packet will match a direct route. All right, it has the direct route that generated by the VBDF20. All right, and then it will send its frame to the VBDF10. All right. And then the VBDF10 will search the MAC address table of the BD10 and find that the destination MAC address is learned from a remote VType. All right. And then the VType1 will send the data frame to the VType2 through the VXLAN tunnel. And you will find that the destination MAC address is the MAC address B. It is the MAC address of the PC2. And the source MAC address is the VBDF10 MAC address. All right, it doesn't matter. So, and after the VType2, it receives this packet. It will check. For the inner frame progress, it will try to check the destination MAC address. It will find that it's not the destination MAC address of if it's local interface, right? It is not the MAC address of any its local interface. So it will try to level 2 forwarding. All right, it will find that it is the MAC address of the PC2, and then the VType2 will only do. Wait a moment, I needed to check it. The VType2 will only do the progress of the MAC address for frame forwarding. All right. So we don't have the level 3 forwarding progress. All right. So that is the asymmetric RB, just because the increase VType and the egress VType they do the different function. All right. Now let's look at what is the symmetric RB. Symmetric RB, it means the egress VType and increase VType will do the level 3 forwarding and level 2 forwardings in the same times. So compared to the asymmetric RB, we will introduce another informations, and this information maybe you will feel familiar. This information is IP VP instance. So what is the IP VP instance? This information is bound to a level 3. We have an information. This information we call it level 3 WinRS. And what is the level 3 WinRS? Level 3 WinRS, it is we will find that the IP VP instance will be bound to the VBDF. All right, it will be bound to the VBDF, and the IP VP instance we will configure the RD values and the RT values, and also we will configure an information. This information is the VXLAN WinR. It is the level 3 WinR. So what is the level 3 WinR? You can just consider it. It is the you can just consider it is MPLS in the label, MPLS VPN in the label. So, for example, for the type 1, we have two VBDF, VBDF 10 and VBDF 20. And for this type, it also have two VBDF, 10 and VBDF 20s. And for type 1, we configure IP VPN instance. We call it VPN 1. And for the VPN 2, we also configure the IP VPN instance VPN 1, and we configure the same L3 WinI. You can just L3 WinI. You can just consider it is the you can just consider it is the MPLS in the label. Just try to imagine what is the function of MPLS VPN in the labels. It is indicate which is the packet, which VPN instance the packet belong to. All right. Now in the we type 1 and we type 2, we have already bound those VPDF into the VPN instance. So it means if we type 1 send a packet to the we type 2, all right, this packet will carry the MPLS VPN in the labels. It is the level 3 when all right. And we have to receive this packet. It will check the level 3 WinRS, and it will know which VPN instance this packet belongs to. So that is why you will find that you will find that you will find that for the level 3 WinR information, we also call it the MPLS labels, just because it is something like the MPLS VPN in the label. And also you will find that a little things is slightly different. You will find that this label is not generated by the BGP. All right, it is configured by yourself, but the function is same to indicate the packet belong to which VPN instance. So now we have already know this information. So we know what is the level 3 VPN instance, what is the IP VPN instance. You find that the IP VPN instance is the same function with the MPLS VPN. All right. So if you want to communication with each other, so we should to belong to the same VPN instance. All right, and we should have the same MPLS VPN in the labels. It means we should have configure the same level 3 VPN. All right, that is the information. So now let's look at how the eVPN RT values and IP VPN RT values work together. So now let's look at the working rule. After a VPN instance is added, the RT carried in the type 2 routers are divided by EP VPN is still remember is still an VPN RT values. The only difference is that the remote and progress the received route differently. In the RT carried in the route is the same as the important RT of the local eVPN instance. The route is accepted. So after the eVPN instance operating on RP routers, it can extract an RP router from the RP router to implement host RP advancement. If if the RT value in the root is the same as the important IP values of the local IPv6 instance, the root is accepted, and the WIP instance that obtains the RP. Notice it is the RB routers carried in the routers. Extract the host IP address and level 3 from the routers. Save the host IP router in the four routing tables, and because the outbound interface based on the next hop of the routers, the final recursion result is the VXLAN tunnel point to the VXLAN. So what does it means? Maybe we can use the figure to explain it. You will find that now for the VType 1, we configure the BD, all right, the BD20, and the BD20 we configure the EVP and RT egress RT values, all right, it is the 21, and this type 2 packet, type 2 routers will be carried by the update message with along with the UAP and RT values, all right? And we type 2 after receive the UAP routers, it will try to check the RT values, just compare it to the local BD, and it will also compare to the VBD if's RT values, all right? If the RT values is equal to the RT values configured in the BD, it will try to pause the MAC address or the AIP MAC address or the AIP informations and install it to the corresponding tables. And if the RT value is also equal to some IP VP instance import RT values that configured in the VP instance, and also in the VP instance should already be bounding to some VBDIF, all right? And then it will try to pause the RB information. What is RB information? RB information, it means the host router, all right? It is host routers. And then it will install the router into the IP VP instance routing tables. So you find that this table is used to, how to say that? Is used to is to used direct the, or we can say that it's used to IP forwarding, but this table is used to direct the, how to say that, the level 2 frame forwarding. So you can find that we just use the one RT values, but we can just to determine if the information can be received or can be accepted by the level 2 layer 2 tables or the level 3 tables. So now let's look at the symmetric RB, the host IP route adjustment, how it works. Now we can find that we have the PUC2. The PUC2 has its MAC address and have IP address. And the switch 2 will learn the AIP address of the PUC2 and generate an RB routers. Notice it is the RB routers, so it means it will have the level 2 WinR and it will have the level 3 WinR. And the level 2 WinR is the WinR that configured inside the BD. All right, we can find that in the BD10 we configured European VPN instance, and it have the RT values. And also for the VBD, we also configured IP VPN instance, and all right, we configure the level 3 WinR and we configure the RT values. But now the RT values in the IP VPN instance and the EVP VPN instance, it is the same. Okay, just to make it easy to understand. And now the RT value, you will find that the RT values and we will carry it. It is the we will carry it. We carried the RT value that we carried is the RT value we configured in the BD, all right, inside this BD. And also we also carried the root MAC. What is the root MAC? The root MAC you will find is MAC B. The MAC B is the MAC address of the VType. So what it is used for, and we will know it soon. And then the switch 1 received this packet, all right. it will try to compare the RT values with its local RT value of IP VP instance. All right, and it will find that switch one, it also have the IP VP instance, and it also has the import RT values it is equal to the RT value that equaled in the BGP update message, and then it will install the information, the host route information, all right, host information to the routing tables, and the label. I mean, the label is the 1000, and the next hop is the WTAP2, and the outbound interface is the VXLAN tunnel. And so what is the communication progress? You will find that the PC1 will send the unicast frame to the PC2, all right, and then the WTAP1 will WTAP1 it will search the routing table, all right, just because WTAP1 is the gateway of the BD10 BD20, all right. And for routing and find that the next hop, the message route is the host route, all right. And then it will try to encapsulate the packet into the VXLAN. You will find that the destination MAC address is MAC B. Notice the destination MAC address is the MAC address of the root MAC of the WTAP2. It represents the packet. It represents the WTAP2 itself. And the source MAC address it will be the WTAP1's system MAC address. And another thing is important, and we should notice is that the VXLAN handler now it is carry the level 3 WIN information, all right. And after the WTAP2 receives this information, it will first it will try to check the level 3 WIN informations and determine which VP instance to forward this packet, all right. And then it will find it should be forward this packet within the IP VP instance VP1, all right. And then it will try to find corresponding routing tables inside the VP instance 1, and it finds that the destination MAC address MAC B, it means it tell the WTAP2 this packet is sent to you and you need to do a level 3 forwarding. So and then the WTAP2 will try to do the entry lookup inside the VP instance 1, all right, and you will find that it will find just the direct route, and then it will send its packet to the PC2. So you will find that in the increase wait type, it do the level 3 forwarding, and for the wait type 2, it also do the level 3 forwardings. So that is the symmetric RRB. So what is different? The different is between the wait type, we need to transfer the level 3 information, and that is the important. So you will find that it's kind of like the MPLS VPN, all right? And now let's look at the description of the type 3 routers. What is the type 3 routers? Type 3 routers, it is inclusive multicast routers. It is its name, but it doesn't matter. So the real things is we need to consider about what information are carried in it and what is the function. We will carry the local VTAP's source address, and we will also carry the level 2 information. So what is used for? It means with those informations, it's defined if we can establish the level 2 VXLAN tunnel with each other, all right? That is the type 3 routers. And you will find that VXLAN tunnel establishment, the VTAPs exchange level 2 WINR and VTAP address information through the type 3 routers. If there are reachable routers between the local and remote VTAPs IP address at level 3, VXLAN tunnel is established between the VTAPs. Additionally, if the local and remote WINRs are the same, an increased replication list is created for bump traffic forwarding. So you find that VTAP 1 we type switch 1 and stage 2, the other we type. This send the type 3 router to each others, and they will find that the WIN information is the same that carried in the type 3 routers. So they will they will build the VXLAN tunnel automatically. That is the function of the, we can see that is the usage of the VXLAN tunnel or VXLAN type 3 routers or the BGP UPN type 3 routers. And at the last, it is the type 5 routers. You can just consider the function is the same with MPLS routers. It is, you can find that it will carry the IP prefix, all right, and it will carry the MPLS labels. It is a level 3 WinIS. So you will find that it is just to tell the VXLAN network how to reach the external network, all right? For example, for the external network, it is a 1.2.3.0, and its mask length is 24, and this route will be imported by switch 1, all right, into the VXLAN domains, and then the switch 1 will send a BGP update message to the switch 2 at the level 3 gateways. And in this message, it will carry the prefix and it will carry the level 3 WinI. It's just to tell the switch 2 which instance, which IP instance the package belongs to. So that is the function of the type 5 routers. And then let's look at some BGP UPN features. All right. And the first features is the ARP broadcast separations. The BGP UPN type 2 routers will enable types to learn MAC address learning without depending on communication with host. However, the ARP requests between hosts still need to be forwarded on the VXLAN overlay network, which will consume a large number of network resources. All right, it will consume a lot of resource of the network. And ARP broadcast splicing can be implemented based on BGP union to reduce broadcast traffic. So let's look at the working mechanism of this. Okay. So for the PC1, it will send an ARP request packet to the PC2, all right? And the WTAP 1 will search the ARP broadcast separation tables on the BD20, all right? And then the WTAP 1 will change the destination MAC address of the ARP data frame from the OFs to the MACB. And then it will encapsulate the data frame into the VXLAN packet and send the VXLAN packet to the WTAP 2, all right? And you will find that for this packet, the original data frame handler, all right, it have already changed from the broadcast frame to unicast frame. And then the WTAP 2 will receive it, and then WTAP 2 will unicast this ARP packet to the PC2. That is the ARP broadcast separations. And this table, ARP broadcast separation tables, is just you can think it is generated by the BGP UPN routing tables. And another thing is the host information collections. To imply the implementation of the ARP broadcast splicing depends on the ARP broadcast splicing tables. All right, the generation of the ARP broadcast splicing entries depends on type 2 routers. And it means the ARP routers and the host ARP advancement generated by the UPN. But by default, the level 3 gateway does not generate BGP UPN routers based on local ARP information. So you need to manually enable these features. All right. So after you enable these features, the ARP information that learned by the WTAP will be transferred to the BGP UPN router. All right, that is the functions. And then now let's look at what is the local proxy ARPs. After the BGP UPN host information collector is enabled on the entire network, the level 3 gateway learns the 32-bit host routers of all hosts. In this way, the level 3 gateway can host the routers to perform level 3 symmetric for the traffic in the same BD. So what it means? It means even it is the inner subnet forwarding, we can use the level 3 forwarding. So what it means? It means we can enable local proxy ARP on the VBDF interface on the level 3 gateway. So the VBDF interface will respond to the ARP request from the downstream host for the IP address on the same network. And then the PC1 try to send a packet to the PC2. You will find that actually they are in the same subnet, all right? But just because the PC1 learns the PC1 learns the AIP information as about the PC2, the MAC address about the PC2 actually is the MAC C. So PC1 will sign this packet here to the WTAP1, and WTAP1 will do the level 3 forwarding. So we will find that between V type, the inner subnet forwarding can based on the level 3 forwarding. That is the local proxy ARP forwardings. And that is the forwarding progress, just because the destination MAC address about the PC1 about the packet that PC1 sent to PK2 is the MAC C, and the WTAP 1 receives this packet, it will do the level 3 forwarding. All right. So what it means? It means between the V type, all right, between the V type, we didn't need to maintain any AIP address, all right. All right, we only need to maintain the local AIP address. AIP address transmitted by another V type through BGP UP routers. We didn't need to use it, so we can find that we can reduce we can configure the anycast gateways, and then the distributed gateway will only the hold the AIP address that learned locally. Any remote IP address will be deleted. That can be just save the results of the IP address. Another features is the market mobilities. What is the market mobilities? Just look at the scenarios. The VM1 now it connected to the WTAP1, and WTAP1 learns ARP information about VM1 and generated and advertised ARP routers. All right, and WTAP1 and WTAP3 will receive this BGP European routers, and this European routers will carry extended communities. We call it market mobilities, and inside this market mobilities, we will carry a sequence. Now the sequence is the 0, and now the VM migrated to another V type, all right? And you will find that the VM1 is migrated to the V type 2, and V type 2 detected the VM1 based on the AIP information and generated a new AIP routers, which is the same as the route advanced by V type 1. And then V type 2 will send or it will update the router to other V types, all right? And now the MAC mobility its sequence will increase, all right? Now the sequence numbers is 1. Now V type 1 also receives the BGP routers, and it will realize the sequence is larger than itself, so it will realize the VM have already migration to another V type, so it will withdraw this router. That is the MAC mobilities. Wait a moment, it should be the last features about the VXLAN. It is the VXLAN queues. We all know that for the VLAN, for the data frame, the origin data frame, it can carry the information about the queues. It is a DSCP. But how do we make sure the information can just come through the VXLAN domains? So we need to use these features. We call it the VXLAN queues. It means we will copy the DHCP value that carried in the VLAN handler to the VXLAN handlers, and then after the packet just alter, will send out of the VXLAN domains. We will copy the VXLAN queues values to the original data part frame. So that is the VLAN queues. You will find that the device map the VLAN queues priorities of the original packet to the internal priorities on the level 2 server interface, and send the packet to a queue based on the internal priorities. and the packet is encapsulated into VXLAN packet. The outer DHCP priorities is mapped from the internal priorities, and then the packet is forwarded to the VXLAN tunnel. And when the packet leaves the tunnel, leaves the tunnel, the priorities information is traced on the tunnel interface is mapped to the internal priorities, and then the packet enters the queue for the transmission. And then the internal priorities of the packet is mapped the to the wait a moment to on the layer subinterface so that the queue's priorities of the packet remains unchanged after the packet passes through the VXLAN network. Subsequently, packets are transmitted based on the mapped priorities. So you can just find that it is a little bit like the TTL replication in the MPLS network. They are the same, just to replicate the information so that make sure the information will not be lost. All right, now we have already finished the 1, 2, 3. The third part. Maybe we can take 20 minutes rest and continue. We will only have some features left: the minicast and the DCR, and then we will have the deployment of the scenarios. And maybe we can have 20 minutes rest. All right. And if you have any questions, you can make comments below, and I will answer it maybe privately or just after we start our lesson. I will respond to you. All right. Now let's take a 20 minutes break. Now we need to introduce another new fundamental, but I thought maybe we can think it is another big features about VXLAN. It is the multicast VXLAN fundamentals. And first, we still need to just we just need to get clear of why we didn't use the multicast overlay multicast. And for examples, we will find that in traditional network, we will use the multicast technology. So for example, we will use the PIM or we will use IGMP just to utilize the or to optimize the traffic forwardings. But how do we do it in the overlay? That is a problem, all right. And we will know that in the VXLAN, the traffic should be isolated. So how do we that when do we do the multicast? So that is a problem. We'll find that maybe on the data plan, the multicast replication function for the bump traffic is used together with the multicast deployment on the underlying network to implement efficient forwarding of the multicast packet on the overlay network. Also on the control plan, next generation multicast VPN is used to transmit multicast control packet across the overlay network and create multicast forwarding entries on the overlay networks. So you'll find that we will use another protocols. It is not the UVPN, it is the NGM VPN. All right, and we will use this VPN to implement the control plan of the overlay multicast. Now, first, let's look at what is the multicast replication for the bump packet. We know that we have already introduced it. By default, the V-type will only do the replication. All right, it is not the real broadcast. All right, it means we need to send the bump traffic one by one to the remote V-type. But we can optimize it. How to optimize it? You can find that we can how to say it? Wait a moment. We can let all the V-types with the same VNI join the same multicast group, and then PIM MMSM is used to create an underlay. You notice it is just on the underlay multicast forwarding entries for the multicast group. And when the source V-type receive a bump packet, it encapsulates the multicast destination IP address into the BAM packet and forward the encapsulated packet to the remote wait type based on the created underlay multicast forwarding address. This will introduce traffic flooding and improve the efficiency of the underlay network in the forwarding overlay BAM traffic. So you'll find that we will use the underlay to implement or use the underlay multicast to reduce the cost of the resource for the overlay. And next is the IP-mix tunnels. So what it means? IP-mix tunnels, it just means the logical tunnels for the multicast forwardings IP-mix tunnels. And the establishment of VXLAN overlay tunnels, we will know. We have already know it depends on the peer information carried in the PMIS attribute. And also for the overlay tunnels, we will also use attribute, but it is not PMIS, it is IPMIS. And these informations will carry the information that we need for build logical tunnels. For example, so we will need to the win information, the multicast group informations and other informations. All right, and you can find that is configurations for the NV interface, and we need to configure the source interface, and we need to configure the multicast group. So it means if we have the same WinI informations, all right, and these informations will be carried by the BGP UAP, BGP MP, BGP NG MPVP NLR, and this information will help the communication. They built the IPv tunnel with each other. And next, let's look at what is the NG MVPN, that information. In certain scenarios, IP multicast is popular among enterprise users because of its high efficiency point-to-multipoint transmission mode. As VXLAN is widely used in DCs, enterprises have increased requirement for running IP multicast service on VXLAN network. EVPN routers are used to dynamically establish VXLAN tunnel on a VXLAN network with distributed gateway and transmit host MAC routers or host IP routers. Implement layer 2 and level 3 communication between devices of the same tenant. To implement level 3 multicast in these scenarios, some NG MVP mechanisms need to be introduced to the control plan so that multicast routing information can be transmitted on the VXLAN information. In this way, multicast forwarding entries can be created on the VXLAN network to guide multicast data forwardings. And now you can find that it is the IGMP report, and this IGMP report information will be carried by the BGP MP routers, and then this information will be received by another WTAP, and this information will generate a multicast forwarding entries, and WTAP 3 will add as the outbound interface of the multicast forwarding entries. So it means you find that by the control plan, by using the NG MPVPN multicast source, it means it will send the traffic, multicast traffic to this, and then this WTAP, we can call it the increase WTAP, will use the IPMIS tunnels forward this packet to the egress WTAP. Now let's look at what is the control plan, or which type of the routers we will use for the NG MVPN. You will find that we will use the 4 type of routers. It is type 4 and type 4, type 6 and type 7. The type 1 is the inter-ES and PMIS AD routers. It is assigned by default after MVPN peer is configured. It is used to automatically discover members in the same MVPN domains. And for the type 5, it is used to advertise new multicast source information discovered during multicast source discovery to other MVPN peer through type 4 routers. So you will find that for type 1 and type 5 is used to discover other peers and build the tunnel with each other. So what is type 6 and type 7? Type 6 it is the short tree join routers, and type 6 is the source tree join routers. So you can consider it is used for the PMDM mode and PMSS mode, but it is in the overlay. All right, it is in the VXLAN. So that is, it means it will carry the multicast informations by use the type 6 routers and type 6 routers, all right? Or type 7 routers, 6 and 7 routers. And then now let's look at what is the logical architectures of the overlay multicast. Maybe we can see the architectures from the top of the layout. And first it is the logical for the overlays. You will find that the NG MVPN peers relationship are established on the overlay network to transmit IP information and multicast control packet. So from the receiver to the source, they are connected to different device, and they are the V type that run the BGP NG MVPN peers, and they will establish the IP tunnel, all right? And the IP tunnel is based on the information transmitted by this router, right? And for the underlay, all right, for the underlay, we will use BGP or IGP to deploy the underlay network, and also we will on the underlay we will deploy the PIM SM mode, all right, just to optimize the PIM IPv tunnels for order efficiency, all right, that is what we do. And now let's look at the working mechanism. First, it is the source-specific minicast. It means the SSM. The first step it is you find that the minicast source, after the minicast source is connected to the leaf 1, the leaf 1 will generate BGP EVP routers and advances it to leaf 2. The route carried the MVP connected community attribute, all right. After receiving the EVP routers, leaf R records the MVP intended address, and which will be used to construct communicate minicast routers, all right. And then the receiver will send AGMP report message to request the minicast traffic. After the message reach leaf 2, leaf 2 will generate PIM SSM join information uses the PIM protocols. And then leaf 2 generate minicast entries, construct a type 7 communicate to minicast routers and send a join message to the leaf 1. And this packet will be sent to the server leaf 1. And the server 1 receives the routers, it will convert it join messages. You will find that it will convert it to a traditional PIM join message and create a minicast entries and establish a minicast distributed trace with the level as a root on the underlay network. So you will find that the server 1 is the root on the underlay network, and it is the outer interface. Use PIM tunnels, it will send the traffic to the server 2. It is the downstream. And then let's look at the control plan about the any source minicast. The progress is first, the HMP report will send to the server leaf, and the server leaf will generate a table, and this table is about the minicast information. So you will find that it is the any source minicast information, and the inbound interface is through the BGP, and outbound interface the VBDF, all right, and then you'll find that for the server leaf, for the RP, it will also construct a PIM minicast routing tables, all right. And the inbound interface is a layer 2 sub interface, all right. It is connected to the PIM source. And for the next step, the type 5 MVP routers, it will send from the server 1 to the server 2 just to indicate where is the source. And then you will find that then the server 2 will receive these routers, and it will change the multicast information to any source, to a specific source. All right. Now just because the server 2 have already know where is the source address, and then it will send the C minicast routers. It is a type 7 routers, okay, to the leaf stream server leaves, and the server leaves will know where is the downstream, and that is the progress. And then we can look at what is the overlay unicast data forwarding progress. All right. First, you will find that the unicast source, it will send the packet to the wait type. All right. And the wait type is the entity that run BGP NGMOPN. All right. And this packet have the destination IP address. You will find that it is the group IP address, and the destination MAC address is also unicast MAC. All right, and this packet will encapsulate to the IPv tunnel. All right, IPv tunnel, and you will find that the IPv tunnel it have a group IP address. All right, and this packet will send to the span and the server level, and then the packet. And the multicast packet imported to the MPU tunnels based on the intra-multicast entries, and then the tunnel endpoint to which the packet is sent is determined based on whether the receiver appears on the control plane. All right, and the packet now will only be sent to this wait type. And after this wait type receives this packet, it will reach the destination leaf node. The leaf node decapsulated the packet to the rest or the original multicast packet and send it to the receiver if the data is requested. If no data is requested, the packet is discarded just because if the receiver have already sent the AGMP report to this wait type, it will generate or it will form the PIM entries and the outbound interface is the VBDF. But if now we don't have the downstream, the packet will dropped by this wait type. Now let's look at some traditional multicast deployment in the DC network. The first scenario is the source is outside the fabric, and the receive is inside the fabric, just like that. You will find that the receive is inside the fabric, but the source, multicast source, is out of the network. And so in these scenarios, the border leaf node will send PIM join message to the PE to divert the traffic outside the DC. So, and between the external RP and the border leaf, this border leaf will function as the RP for this VXLAN domain, and they will establish the MSDP peer, all right, just to exchange in the information about the multicast receiver and the multicast source. And the external RP locations and deployment mode. And we also need to notice that the interconnection mode we need to establish between the external RP and border leaf. And another scenario is the source inside the fabric and the receiver is out of the fabric. And actually, the things is the same. We need to build the external build the MSDP peer between the external RP and between the border leaf. And the external RP will join or will send the PIM join message, and this message will be just convert from the traditional PIM message to BGP NG MPP message, and this message will be sent to this wait type. All right. And another scenario is both the multicast source and the receiver are inside the fabric, so the things will not be different. We just need to or deployment the NG MVPN, and we need to deployment the PMSM in the underlay. All right. And for the underlay PMS multicast, we need to see the configuration key point. And for example, for the span span device, we need to deployment the unicast RPs, and all right. And for this wait type, we need to configure the IP, all right, and we need to configure the IP tunnel, and we need to configure the BGP NG MLP, all right. And then now let's look at what is the control plan, how to implement the control plan of the overlay multicast. You will find that the span device, they will function as the RR, all right, function is RR, and for the border leaf, and for the server leaf, they will function as the NG-MVM client, and this is RR, and the NG-MVPN routers will be exchanged between the border leaf and the server leaf. Now we have already finished the part of the multicast VXLAN fundamental, and now let's into another chapter. It is application of the VXLAN in DCI. So what is the DCI? DCI means now we have two different data centers. Maybe they are located in the same cities. Maybe they are located in the different cities. Maybe they are in the same VXLAN domains and have the um, same plan of the VXLAN, but maybe they don't have. But now we need to just make they can communication with each other. So that is the DCI. It means data center interconnection. So we have different mode in the real network. The first one is the end-to-end VXLAN. It means the end-to-end VXLAN tunnel. And another one is the VLAN handoff. It means between the VXLAN, it means the packet will just leave the VXLAN domains and into VLAN domains and then re-enter the VXLAN domains. That is VLAN handoff. And the last one is the segment VXLAN. It means between the VXLAN, between the two DCs, we will use a segment, and inside the DC itself will use a segment. So we will have three segments with a segment to finish the VXLAN DCI. And the first thing, let's look at what is the underlay deployment about the N2 and VXLAN. So the key point is we need to make sure every node, I mean the server leaf, I mean the V type, can communication with each other, communication with other V type in other DCs. So maybe we can use the BGP. All right, maybe we can use the in the DCI leaf we can use the eBGP PS, and between the inside the fabric we can use the OSPF, and then we can import the OSPF into the eBGP PS, so that for this V type and this V type they will have the route that's sent to each others. And for the overlay, we have different method. For the first method is we can configure the BGP UAP partnership between the server leaves. All right, you will find that. And span out and between nodes, DCI leaves nodes, and a UAP peer relationship established between DCI leaf mode. And the function of the node changes next hop of the routers is able. It means for the server leaves or for the DCI leaves or the span device, they will not change any information about the BGP European routers. So, for example, if the server leaf send the BGP European routers to the span, and the span send it to DCI leaf, and DCI leaf to another DCI leaf, and then the packet, the BGP router will be received by server leaf. Nothing changed. So the server leaf will see the VTab address, see the real next address, see the VN address, so they can communication. So they can just use the Type3 routers to build a VXLAN tunnel. All right. So in this way, the two DC they are in the same VXLAN domain. And another VXLAN method is we can use the RR. It means the span will function as R. DCI leaf and all the server leaves will function as the RR client. But the thing is the same, and it means unchanged as a help. This feature will be enabled on the RR and DCI leaf and server leaf. Now let's look at what is VLAN handoff. VLAN handoff, you can find that between usually in the same or different AS. Actually, they need to in the they can in the same AS. Fabric 1 and Fabric 2 are usually in the same AS, different AS. They should be in the same AS. And I remember if you see the document about the product, they will tell the traditional configuration examples for these scenarios. And I remember all they are in the same AS, but it doesn't matter just because it means they need to actually, although we are in different fabric, but we have the same plan about the VXLAN. It means the VNI need to be the same. And another scenario is the VLAN handoff. VLAN handoff, it means you can find that between the baud leaf and the server leaf, it is the VXLAN tunnels. But after the packet leaves the baud leaf, it will also leave the VXLAN domains. It will enter the VXLAN VLAN. All right, and this VLAN, I mean the VLAN packet. I mean maybe you can see we have a VLAN tunnel. The VLAN tunnel and this VXLAN tunnel, they are mapped in 1 and 1, and then the VLAN will also will be mapped to VXLAN tunnel again in the DCI leaf. So you will find that from this server leaf to this DCI leaf and to this DCI and then to this baud leaf, you can make sure we use different tunnels. We use the different VLAN packet, but we can make sure the packet is still in the isolation. That is the VLAN handoff mode. So you can find that from the VXLAN to the VLAN and then to the VXLAN, VLAN to the VLAN to VXLAN, and then to VXLAN to VLAN, and then again to VLAN to VLAN. You find that now we can use the VLAN handoff mode to implement layer 2 communication. But how? But maybe I can ask a question: if it can meet the level 3 communications, it can, but it's complicated. It is not simple. So it means for the two baud leaf, we need to just define just a VLAN, and this VLAN is specific for the two baud leaf, and the two baud leaf will build BGP European peers and just to exchange the routers, and it means for this baud leaf and this baud leaf, the route about the VXLAN domain about the service is just like the traditional private routers, and it will be exchanged between the baud leaves, and the baud leaf will use this, I mean this logical level 2 link to finish the transmission. So you find that it is not like VXLAN communications. The VXLAN communications just between baud leaf and server leaf. For the baud leaf and this baud leaf, they are more like communication in the MPLS VPN. Right. So VLAN handoff can implement the level 3 communications, but it is not the future of it itself. It just means you can use some features to implement, but it is not supported by it natively. So now let's look at the forwarding progress. You can find that the intranet packet in the DC1 reaches the baud leaf, and then it will leave the VXLAN tunnels, and then it will into the VLAN packet, just because this VLAN have already been mapped to the BD in this interface. And then after the packet reaches the DCI leaf node in the DC1 through a layer 2 subnet interface, the DCI leaf node and it will re-encapsulate through the packet into the VXLAN packet again, and send the packet to the remote DCI leaf mode. And then the packet will leave the VXLAN tunnels and into the VLAN packet, and then it will re-enter the baud leaves. So you will find that we need to make sure the encapsulation or the mapping information is the same. So we can make sure the server leaf, this server leaf can communication with the server leaf. That is the VLAN handoff. And now we need to look at what is the segment VXLAN mode. And for the underlay for the segment VXLAN, we need to make sure the device, I mean the DCI leaf, they can communication with each other at level 3. But what way you use that depends on you. You can use the DWDM, it means the optical transformation device, or you can use the MPLS VPN, or you can use the SD-WAN. It doesn't matter. It depends on you. You can choose different method. And BGP is deployed on the DCI leaf node, and the BGP routers are imported to the OSPF to ensure that the DC has the reachabilities on the routers to each other. So it also requires they have the reachabilities to each others. But what is different? The different it is the overlay. So you will find that we have 3 segments of the VXLAN tunnels. The first one is from the server leaf to the DCI leaf. Another one is between the DCI leaf, and the third one is from the DCI leaf to server leaf. So what is important? Important, we need to enable a feature. This feature will let the VNI, next hop, and in source address will be changed by the DCI leaf node. So what it means? It means the server leaf sends the packet to the DCI leaf. Once the DCI leaf send this BGP UEP router to DCI leaf, this DCI leaf, all right. Wait a moment, I need to, all right, just like this. When the DCI leaf sends the BGP router to this DCI leaf, it will change the VNI, the inner source address, the next address to itself. And when this DCI leaf sends the BGP UEP router to this server leaf, it will also do these things. So for this server leaf, when it try to send a packet to this server leaf, for it will know the inner source market is this DCI leaf. The next hop is this DCI leaf. The winner is this DCI leaf. So packet will send to this DCI leaf, and then it send to this DCI leaf, and then it send to this DCI leaf. So in different VXLAN tunnels, it has the different encapsulation winner, next hop, and in MAC source, just like send the message hop by hop, and every hop will change the message to itself. That is the segment VXLAN. And now you can look. It is the segment VXLAN mode, but it is for the level 3 communications. For the level 2, it will be slightly different. First, you will find that the WTAP 1 it receive a packet from server 2, and it is sent to server 1 sent to server 2. Server level 1 will find that the corresponding level 7 VPN instance through VBDF10 because the access is a closed network segment. After searching the table, server leaf encapsulates the packet into a VXLAN packet. With the next hop is WTAP 2, you will find that the next hop is WTAP 2. Actually, the VNI information, the inner MAC address also is the WTAP 2. I mean, it is the DCI leaf, this DCI leaf, all right. And then this WTAP 2 will decapsulate this packet to VLAN, and then it was re-decapsulated to VLAN packet. And you will find that after receiving the VXLAN packet, DCI leaf find the level 3 VP instance based on the level 3 VNI. Search the table and encapsulate the packet into the VXLAN packet again. And then the next hop is being WTAP 3. Notice now the VNI, the inner source MAC address, and the next hop change again. And then WTAP 3 do the same things, and WTAP 3 will forward it to the server level 2, and all the information, I mean, just beside the inner frame, all the information change again. So that is the level 3 communication. And for the level 2 communications, we have different mode. We have the local VNI mode, and we have the mapping VNI mode. So what it means? It means one I mean they are in different segment, so they are in different broadcast domain. They will send the BGP UEP router to each others, and they will use the different VNIs. So it means now you will find that WTAP 2 send the type 2 router to WTAP 3 use the L2 VNI 100. It means when the WTAP 3 send the packet, I mean the data, I mean the forwarding plan. When it sends the packet to the WTAP 2, it will use the level 2 VNI that sent by WTAP 2. And for the WTAP 3 and WTAP 2, when the WTAP 2 sends the packet to the WTAP 3, it will be vice versa, all right? And that is in the local VNI mode. So you will find that from the server 1 to the server 2, right? In server 2, in this DCI leaf, the VNI will change from 100 to 200, all right? That is the local VNI mode. It means I will use the WinI that you send to me. That is the local WinI mode. So what is mapping WinI mode? Mapping WinI mode, it means we will use another new WinI. For example, inside in the AS100 in the DC1, for this segment we use the WinI 100, and for this DC2 and in the AS200 we will define a new WinI. It is 200, so it is different. But for communication with each other, so we will use another new WinI. It is WinI 300. That is the mapping mode. So for the communication, you will find that when the packet reaches the DCI leaf, the DCI leaf will transmit the WinI value from 100 to the mapping value, and then when the packet reach to the destination we type, it will transmit the WinI value from 300 to 200. That is the mapping WinI mode. All right. Now let's look at some key configuration point in the segment VXLAN mode. You will find that we have already seen we will regenerate the next hop, the WinI, and the in the MAC address. All right, so we will use this command. All right, we will use this command. We will use this command import regenerated and advantage root regenerated UAP MAC and IP and UAP IP. So it means this for this command we will regenerate the type 2 router, and you should know that it means for the MAC address information, but for this one it means we will regenerate the host I mean the RP router. All right. And for the level 2 communications, we need to configure the split group. That is the you can think just it is a regulation. We must configure the split group, and you need to configure the DCI leaf and the server leaf to different split group in the same different configure it to different split group. And for us, it is the same. You will find that we just need to configure for level 2 communication. So we just need to regenerate the type 2 route, and it is the type 2 route about the MAC address. We don't need to regenerate the information about the type 2 RIB route. All right. And for the mapping, it is the same. All right. For the mapping WinI, but we need to configure the a new WinI for the split group. All right, and that is the different between the configuration. And now let's look at what is the different. Oh, all right, we can do the comparison between level 2 and level 3 design mode. And for examples, you will find that for the end-to-end VXLAN mode, they need to in the same VXLAN domain, and you will find that we need to use the same WinI plan. All right, so it means we can't to address two large scale. Just because if we have different different data centers, we need to plan the WinI information for the subnet in the same way. So that will waste it will waste a lot of WinI numbers. And for the VLAN handoff, you will find that we can only use it to meet the level 2 DCI interconnection. All right, and but it can use for large scale data center. All right, and for what is the segment VXLAN, you can use the B to the level 2 DC and level 3 DCIs, and it doesn't require you plan the VXLAN in different data centers as the same way. All right, so you will find that normally in the real network we will use the segment VXLAN, but the segment VXLAN is I mean the configurations is the most complex for compared to other ways that is more complex. All right. Now just let's look at a simple case about the deployment. All right, it is about the distributed gateways, and you will find that we have these topologies. We have the span device, and this leaf 3A and leaf 3B is the border leaves, and we have the server leaves. All right, and we have 3 services, service 1, 2, 3. And let's look at what we need to configure. The requirement is we need to use the BGP VPN to construct the VXLAN network, and it should be deployed in the distributed gateway mode. And the spines function as RR to reflect VPN routers to implement Level 2 and Level 3 communication between services. And mlog is configured on all Level node to ensure access link reliabilities. And configure egress routers on Level 3 and to allow server 1 on the internet to access the internet. So let's look at what is the configure procedure. The first one is configure the mlog, but I thought it should not be mentioned in this place because it is not the most important part for this case. And also for configure the underlay, configure the IP address of the device. It also is it will also be displayed in this case. And we'll configure the BGP and enable the BGP UMPS, and we will configure the VXLAN tunnels. And I thought these tunnels should be use the automatic mode, and we configure the VPN and the VPN instance, and we need to configure the Level 3 gateways. It means we need to configure the VBD and we need to configure the access point and the egress routers. And also, I think we need to import the egress routers from public VPN instance to the IP VPN instance for the VXLAN domain. All right, I thought you should know that. Now we have a terminology. We have a bucket, just a figure, just to tell you how do we plan the IP address, but it doesn't matter. All right, we just need to configure the config progress. For the mlog config, I thought we just we can just see it after this class. But we can see what we configured for the BGP and BGP VPN. First, you will find that we will configure the BGP relationship between leaf and the spine device. You find that we first we need to enable the function for the BGP VPN, and this command is the VPN overlay enable. And we need to configure the BGP VPN relationship, and we need to enable the level 2 VPN peer relationship, and we need to configure it as the RR client, and we need to configure it to otherwise RB. And for other leaf, I mean, in the spine one it is the same, so we are not mentioning here. And for the spine 2, it is also the same. And then we need to configure the European pairs. You will find that we need to configure for the I thought it should be the live 1A, live 1-2B, and live 3A, but we use the similar drives for the mlog system. And then what is important? And then we need to configure the VXLAN tunnel. You will find that we need to configure the bridge domain and map the VXLAN WinI to the bridge domain. And also we need to configure the NV interface. We need to configure its source IP address and configure its which MAC address, and we need to configure the hand and the way to establish the VXLAN tunnel by use the BGP protocols. And then we need to configure the European instance. You can find that we have already configured the European instance. We need to configure the RT values, and we need to configure, and that is used to transmit the BGP European information between the live device, and to limit it if they can communication with each other. All right, and then we need to configure the wait a moment. And also we need to configure the IP VPN instance. You will find that for the IP VPN instance, we also need to configure the level 3 VPN. We need to configure the VPN RT VPN instance. All right. And then we need to configure the distributed gateway. We need to configure the VBD on the live 1, but on the live 2, it is configured the same. So we didn't mention here. You find that we need to configure bound it to the VPN instance. We need to enable the ARP collector or the enable features. We need to enable ARP distributed gateway these features, and also we need to configure they have the same which MAC address. All right, just because they are distributed gateway, but they should have the same MAC address. So before and after migration, the server will don't need to learn the IP information again. And now it is the configure the routers. You find that this routers on the level 3A is configured to the VPN instance, all right, and then we need to import the routers into the VPN instance. And then for the level 1A, we need to configure import the direct routers and advantage the level 2 VPN routers, right? And at last, we need to configure success point. We will find that because it is an MLOG system, so we need to configure it in the sub-interface about the easy trunk, all right? And configure it uses level 2 sub-interface mode to bind the VLAN to the bridge domain. And then as a result, you will find that the on the level one, you will find that they have established the VXLAN tunnels, and on the level 1, they can see the default routers to the external network, and for the level 3, you can also see it. That is the case, and actually, we will have the configuration lab experiment, and I think another teacher will give you the experiment in the next day. So he will show the huge progress and show the command and show detail configuration and the output about the lab. So you can, I think you can expect it. Now let's look at sim quiz. The first one is the eVPN Type 2 host IP routers can be used to transmit IP information. We know that it is right, all right, just because host IP routers will include all the information that be carried in the AIP information, all right. So you can see that AIP information is the partition of the IP router. And then it is the single answer questions. Which of the following statement about BGP eVPN is false? The first one, it is carried by the MP region. Yes, it is right. And carry that through the extended communication routers. All right. And carry level 2 winner and level 3 winner in the MP is also right. But the second one, no, it is the last one. Carry the next hop address of the route through the next hop attribute. You will know that all the how is that address family? I mean the sub address family that use the NP reach NLRR. They will not use the next hop attribute. They will carry next hop in the multi-protocol reach NLR. All right. Now let's look at the summaries. VXLAN uses the level 3 routed network as its underlay network and use tunnels to build an overlay which network supporting a large number of the tenant networks. And VXLAN does not define the control plan, so you will find that the VXLAN itself have some disadvantages. To overcome those advantages, we need to introduce a new technologies, and that is the BGP UAPN. All right, and the BGP UAPN can just solve the problem perfectly. But for the multicast traffic, it doesn't have good ways. So we introduce another protocols, the NGMP. All right, and also we introduce how to implement the interconnection between different data centers. And I hope you have learned some things. And if you have any questions, you can make comments below. And I hope another teacher will meet you guys in next training, in today's trainings. And now we have already finished today's training. If you have any questions, now I will give you time. You can type it.